Hello friends, welcome back to my video lecture. In this video lecture, we are going to see distinguish between the mass and weight. First of all, we should know what is meant by mass and weight. So, the table is given in front of you. The mass, we have know that the amount of matter present in the objects. So that is the definition for the mass. And the weight is the force with which the earth attract the objects. Now see the difference between them. The mass does not change with the place. If you will see, for example, if you will take 1 kilogram of anything and you will take weight up on the south pole, and if you will go to the equator, so there will be no change, okay, into the mass. So that, but you can see into the weight of an object change with the place. That means if you will see, in case of weight of an object change with the place. So next is SI unit is the kg, and the SI unit for the weight, that is Newton, and the mass is the scalar quantity and the weight is the vector quantity. So like this we have to remember the difference between the mass and the weight. The mass is denoted by small m and the weight is denoted by capital W. Now we have to see the familiar expression of weight and the mass. We have know that the W is equals to mg, and here the W stands for the weight of an object and the mass stands for, that is small m is denoted by mass, right? And the g is the acceleration due to gravity, and the you will see the value of g is the maximum at a pole of the earth, that is 9.83 meter per second, okay, meter per second. Now at the equator the minimum value will be there, so that value is the 9.78 meter per second. So we have now these values which are actually present on the earth, that is acceleration due to gravity. And the mass of the earth, you will see the mass of the earth, that is 6 into 10 raised to 24 kilogram, and the radius of the earth 6.4 into 10 raised to 6 meter. So we have now this thing related to the earth. Now we have to see the next topic, that is mole. If I want to count the amount of the chemical substance, so what I can take, in which thing I will measure that things, or you can say amount of the chemical substance. So it is the SI unit for the amount of chemical substance, right? And it is always associated with specific microscopic quantity such as atoms, molecules, ions, electrons, protons, and other smaller particles. So the very minute particles we can't measure into the different units. So that minor particles or minor thing or very smaller thing we can measure into the moles. And proper definition for the mole, that is the amount of the specific substance that contains the same number of particles as the number of carbon atom in exactly 12 grams of 12 carbon. If you will take the, for example, carbon, so the mass of the carbon is 12, so the 12 mass of carbon is equals to 1 mole of the carbon, right? And the formula, if I want to calculate the number of moles, so I will use this formula. Number of moles is equals to mass of particular chemical compound and the molar mass of that compounds. Okay, so this formula I will use for the number of moles calculations, and the important number is Avogadro's number, that is denoted by Na, capital Na. 023 into 10 raised to 23 is equals to 1 mole, and the mass of whole compound, that is 1 mole. Example, the molar mass of acetic acid, that is 60 gram. How we can calculate the molar mass of acetic acid is 60 gram. So in this way we can see, that is the formula for the acetic acid, CH3COOH, and in this way you can calculate the molar mass of acetic acid. So the number of carbon is present, that is carbon 1 and 2, so here 2, right? And the mass of the carbon, that is 12, right? So 12 into 2 is equals to 24, and the number of oxygens are 2 into mass of the oxygen, that is 16. So 16 into 2 is equals to 32, and the number of hydrogens are there 4, and the mass of the hydrogen is 1. So 4 into 1 is equals to 4. So the total addition of 24 plus 32 plus 4 is equals to 60. So in this way we can calculate the molar mass of acetic acid, right? Now next example, you will take glucose. The molecular formula for the glucose, that is C6H12O6, and in this way we have to arrange again number of carbon, that is 6, okay, into 12. So 12 into 6 is equal to 72, and the number of oxygens are 6 into mass of the oxygen, 16 into 6 is equals to 96, and the hydrogens are 12 into 1, mass of hydrogen is 1, is equals to 12. So addition of all these thing, 72 plus 96 plus 12 is equals to 180 gram. So that is the 1 mole of glucose, right? So in this way you can calculate the molar mass of any kind of chemical compounds. We should know the atomic mass of that elements, right? Now see the next terms, that is millimoles, okay? So the millimoles is the sometimes the amount of chemical substance in mole is very small quantity, so that times we can use the millimoles. The number of, like this, you have to take 1 by 1000 or 10 raised to minus 3 of a mole, and the mass is in a grams of a millimoles. And the formula for the number of millimoles, if I want to calculate the number of millimoles, you will take the number of moles divided by 10 raised to minus 3. So by using this formula you can calculate the number of millimoles, right? Now see the example based on these terms, moles and the millimoles, okay? So examples you will see here, calculate the number of moles and millimoles of benzoic acid that are contains in 5 gram of the pure benzoic acid. The given values are, molar mass is given of benzoic acid, that is 122.1 gram per mole. So that is the molar mass for the benzoic acid, right? Now see the solution. First of all, we have to calculate the number of moles of benzoic acid, and we have know the mass of benzoic acid, okay? And the molar mass of benzoic acid, that is given for you, okay? So both values we have, right? The mass of the benzoic acid is given, that is 5, and the molar mass is also given. So we have to take this formula, and simply we have to put this value, and we can calculate this simply in this way. So 5 gram divided by 122.1 gram, so you will get 0.0409 mole. So that much moles are present of benzoic acid in amount of substance. Now next thing, the number of moles of benzoic acid, that is this one, and the millimoles, we have to calculate the millimoles of benzoic acid, and we have know that formula, the number of moles of benzoic acid. So that value we have to put into this formula, and next 1 by 1000. Okay, so after calculation you will get, so this value you can write here, and into 1000, so you will get 40.9 millimoles. So that is the millimoles of the benzoic acid. Okay, 40.9 millimoles. Now next topic we are going to study, that is the significant figures. Very important topic for you in point of examination. The most valuable digit in the given number is called the significant figure. How we can identify the number of significants which are present in the specific number? So that based on the some rules, we are going to see that rules. In that, first of all, we are see the importance of the value. Okay, if you will take the 100 here, so the importance of 0, that is value for the 0 into the 100. Okay, but if you will write the 0 in front of 1, okay, so before the 1 you will write the 0, so there is no importance of 0. So that is the importance of specific digit into the number, right? Now we are going to see the rules. Okay, with the help of this rule we can calculate the significant figures. Okay, we have to apply all these rules for the identify the significant figure. So first rule, that is all non-zero digits are significant figure. For example, you will take 1 2 3 4 5 6, so all they are non-zero digits. So 1 2 3 4 5 6, 6 in this number, 6 significant figures are present. Now the second rule, that is all zeros between two non-zeros digits are significant figure. If we have know that now, so all they are non-zero digits, and between the non-zero digit zeros, it means this 0 and this 0 and also this 0. So all there also we can count as a significant figure. So in this number 1 2 3 4 5 6 and 7 are significant figures. So in this way we have to apply the rules. Now third, all the zeros on the left of decimal and the right of the decimals are not significant figure when the number is less than 1. Okay, when the number is less than 1, so right and left of the decimal there will be 0, so we can't count them as a significant figure. For example, you will take the 0.00313. Okay, so the decimal point is here, and the left hand side this 0 and right hand side these two zeros, we can't count as a significant figure. So except these zeros we can take this number only, 1 2 and 3. So in this number 3 significant figures are present, right? And the next rule, the number is greater than 1 with decimal, then all the zeros on right side of decimal and the left side decimal will be significant figures. Okay, so opposite rule is there to the third rule. Okay, if the number is the greater than 1, so we can take whatever the numbers are present that we can count as a significant figure. So in this case, in this number 1 2 3 4 5 6 7 are significant figures. Now next rule, the number of without decimal, all the zeros on the right side will not be significant figures, but when it comes from the measurement then zeros are significant. For example, you will see here 2000, sorry, 200. So in this number there is no significant figures, but after the measurement you will see 200 gram. So the gram is measurements come from the this number, so that's why the three significant figures are present in this number. So that is the, like this we have to apply this rule for the significant figures.